Hello, welcome back to Algebra. The title of this lesson is called Synthetic Division, Part 1. We're going to have several lessons here, increasing the problem complexity, but the most important point here in the beginning is to really understand what synthetic division is, why we use it, and to understand where it comes from. I could just give you the procedure and you could do it, but I want you to know where it's actually coming from. So in the last few lessons, we learned how to divide polynomials. And if you're anything like me, or like most students, you pretty much find long division of polynomials to be a pain. It's just because there's a lot of things to write down, a lot of cumbersome subtractions, and so on. So there is a method to do that long division in a simpler way for certain kinds of problems. I need to say that one more time. There's a way to do that long division in a much, much simpler way, but only for certain kinds of problems. There's a certain type of division where you can use this concept called synthetic division to make it simpler. Specifically, if you're dividing by the very specific form, if you're dividing something by like x minus a number or x plus a number, then you can use this synthetic division. So for instance, if you're dividing some polynomial, if you're dividing it by x minus 1, you can use synthetic division. If you're taking some polynomial dividing by x minus 10, you can use synthetic division. If you're taking some polynomial dividing it by x plus 3 or x plus 7 or x plus or anything like that, x plus a number or x minus a number, if you're dividing by that, you can use synthetic division, and it's much, much faster than the long division. So you cannot use synthetic division for problems where, for instance, you're dividing by x squared plus 2. The x squared kills it. You can't use synthetic division. If you're dividing by x cubed minus 9, you can't use synthetic division. So when you're dividing by x plus a number or x minus a number, we can make our lives much, much, much easier by doing this. So what we're going to do now is I'm going to do a long division problem to kind of keep it in our mind. And then we're going to do that long division problem in parallel by using the synthetic division procedure so you can see where it comes from. And then we'll work a few problems, additional problems in synthetic division so that you can get some practice. So before I can introduce the synthetic division, we need to do one quick problem in long division. And I know that we just did this in the last lesson. But it's really, 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 really helpful to have a problem in your mind when we do the synthetic division. So this one's not going to be hard. So we're going to take the polynomial 2x cubed minus 7x squared plus 0x plus 5. Notice we have a 0x. So remember, when we do division, we have to pad any missing powers. We have an x cubed, x squared, x to the first, and then no x at all. We have to pad any missing x's, variables there with a 0 there. And we're going to divide that by x minus 3. Now notice right away that this problem is set up. I'm going to do it in the long division format, but because we're dividing by x minus a number, or alternatively x plus a number, I'll show you in a few minutes, then we know we can use synthetic division, so we will do that in just a minute. So in order to crank through the long division procedure, what do? We take a look at the first term here and the first term here. X times something has to give me this. So there's a 1 out here, so 1 times 2 is 2, and x times something is x cubed. This has to be an x squared. All right, now we go backwards and we multiply. The 2 times the 1 gives me a 2, and the x squared times the x gives me x to the third power. And then the 2 times the negative 3 is going to give me negative 6, and then the x squared times the 1 is x squared. Now I need to subtract both of these from their partners above, so I'm going to put a minus sign. I'm going to put a circle around it to remind me that I'm subtracting directly from above. And by the way, if none of this looks familiar to you, then it's just because you haven't watched my lessons on long division. So if this looks crazy already, then go back and watch those lessons. I have entire lessons explaining every little part of this process. So we have the 2x cubed minus the 2x cubed. That's going to give me a 0, so I don't need to really write it there. But this negative 7x squared, subtracting a negative 6x squared, really becomes negative 7 minus 6. So negative 7 minus a negative 6 is basically negative 7 plus 6. So it's going to be negative 1. I'll put it like this, negative 1x squared. So you have to be careful when you do the subtraction. Negative 7 minus a minus becomes negative 7 plus 6. So once I've done the subtraction, I take my next digit and I bring it down, which is 0x. And then I start again. X times something will give me the negative 1x squared. It has to be a negative 1x. So I take and multiply this direction. I'm going to get negative 1x squared. And then the negative 1x times the negative 3 is positive 3x. Again, I need to subtract. I'll put a negative sign there with a circle to remind me that I'm doing both terms. This minus this gives me 0. 0 minus 3 gives me negative 3x. Gives me negative 3x. And then after I've done this, I drag my next term down, which is a 5. And I look at the first terms. X times something gives me negative 3x. I have to have a negative 3 here. And then I multiply. This is going to give me negative 3x. And then the negative 3 times the negative 3 gives me positive 9. Almost done here. We subtract both terms. These give me 0. 5 minus 9 gives you negative 4. Okay? Gives you negative 4. So we have done this numerous times before, and now that we have the whole number of times this can be divided in and the remainder part, the answer to this problem is what we have written above here, 2x squared minus x minus 3, and then we have a fractional remainder part, which is negative 4 over what we have out here, x minus 3. So this is kind of the remainder is a fraction of what you're dividing by, so this is kind of the fractional part of the answer. And we talked about that before. This is kind of the whole number part of the answer, as we've talked about before. So this is the answer. Now, why am I doing this? Because in order to explain what long division is, you have to have in your mind a concrete example in order to explain what synthetic division is, you really need to have in your mind what a problem feels like from long division. We can all agree that this is a real pain. What are the real problems with this? The first problem is I have to write all these x's down everywhere. There's x's everywhere. It's just completely filled with x's, x squareds, x cubes. And so I know we're doing it to keep track of it, but that's obviously something that's not good. Another thing that's not good is that this subtraction process is really cumbersome, because you have to be careful when you're doing negative 6 minus a minus 6. It's really negative 7 minus a minus. It's really negative 7 plus 6. And so it's very, very easy to make sign errors when you're subtracting negative numbers and they're all spread out like that. That's the number 2 thing. So synthetic division is a faster way to do this process. It's actually lightning fast. You don't have to worry about the crazy subtraction. You don't have to do that. And also, as a bonus, you don't have to write all those x's everywhere, so the problems don't take up the whole page. So what we're going to do now is we're going to talk about the concept of synthetic division. If I can spell synthetic. Division. Right? Synthetic division, right. All right, so I've already told you a few times, but basically you can only use it. It's a faster process, but it lets us divide when the divisor, that means what you're dividing by, must be, I'm going to write it as x minus a number, but keep in mind this number can be positive or negative. So when I say x minus a number, it can really be like x minus 2, I can divide by this, I can divide by x minus 19, that's fine. I can also divide by x plus 3, I can also divide by x plus, whatever I want, 18. Right, so when you see x minus c, it doesn't mean it has to be x minus something. Consider that c can be positive or negative. So really it's better to say that you can use synthetic division when you divide by x plus a number or x minus a number. All right, so what does it look like? First, I'm not going to show you how to do it yet. I'm going to show you what it will look like. And then I'm going to show you how to do it. Here's what you do. This 3 out here, see how it's x minus a 3? In synthetic division, it's x minus 3 you're dividing by, but you don't write the minus 3. You write it as a positive 3. And then everything on the inside that you're dividing by, you write all the numbers down, right? But you don't write these variables now. So I'm going to show you how to do it, and we're going to talk about it just a second. So the 2, the negative 7, the 0, and the 5. And then instead of doing a traditional division bar, you kind of go upside down and kind of write it upside down. You'll see why in just a minute. So you can see when we write the problem statement like this, all of the important information is contained because all polynomials are going to have these coefficients. Even if there's a 0, we have to include it when we're doing a long division. So really we're just not writing all these x's everywhere, but we know that this has to be a 2x cubed because this has to be constant. So this has to be 0x, so this has to be negative 7x squared, so this has to be 2 times x cubed. So you kind of go backwards and you can reconstruct what the polynomial is just by the numbers. All right? Now, I'm not going to show you how to do it yet, but we go through this process that I'm going to show you in just a minute, and what you're going to end up with is with some numbers down here, right? And then you're going to have a line here, and then you're going to have some numbers down below. I'm not expecting you to understand this yet. I'm just showing you how it is set up. So what happens is when you do the process, which is very simple, what you end up with is the first 3 numbers that you get, or I should say, let me back up and say it this way. The last number that you get, this is the remainder. Notice I got a -4 there. The remainder in our long division was actually a -4. Now all of the numbers to the left of this are basically the whole number part. So this is the remainder, this is the rest of the guy here. And this means 2x squared minus x minus 3. So notice this polynomial is what we got. The 2x squared minus 1 minus 3, that's what we got up here. The remainder in long division is way down at the bottom, and then you have to reconstruct the answer, as we've done many times. In synthetic division, when you do the process, the very last number you get on the right is the remainder, and then the numbers to the left represent the whole number part of the polynomial, the rest of the answer basically, which we can reconstruct here. All right? And then, of course, I've already said it to you before, but I'll just kind of like point it out 100% clear. This represents 2x cubed minus 7x squared plus 0x plus 5. That's what that represents. And then this represents x minus 3. So if you have x minus 3, you put a positive 3 that you're dividing by. If you end up dividing by x plus 5, then you'll have to put a -5. So whatever the sign is that you're dividing by, you put the opposite sign in your synthetic division. All right, I don't expect you to know anything about how synthetic division works yet. I haven't taught you that. All I'm showing you is that when you write all the numbers down, this is what they mean. The number on the outside of the little house is what you're dividing by, but you have to use the opposite sign, okay? The numbers on the inside of the house is what you're dividing into, and then the numbers on the bottom represent the remainder along with the rest of the answer, as we have done in long division. All right, so now it's time to, let me see where I want to do this. I think now it's time to actually do this problem, right? And show you where it comes from. So I'm going to rewrite everything in purple here. I'm not going to write the answer down. I'm just going to rewrite the problem statement here in purple as if we're dividing these polynomials together or into one another. So I have a 3 outside the house, and then I had a 2, a -7, a 0, and a 5. And you draw like an upside down division symbol, sort of, right? Here's how you do it. You write this problem statement down, and then you draw a line there, and then you draw a little arrow. I do this anyway, and you need to drop down the first number, okay? The first thing I want to show you, actually I forgot to mention it to you, is one very, very important thing. I'm sorry I didn't mention this before. When you're doing long division, obviously everything written on here is important, but when you're doing the subtraction and you're working through this black part here, you see how the 2's are subtracting, the -1's are subtracting, the -3's are subtracting, and so on. The most important numbers are these numbers boxed in red. You have a -6. Let me just double check myself. You have a -6, you have a 3, and you have a 9 here. Why are these the most important numbers? Because these are the numbers that you get basically when you do the multiplication down and then you need to subtract, right? So these numbers give you the next line in the process. So notice that the -6, the 3, and the 9 are also present in the synthetic division here, but they're opposite signs, right? So whereas when you were dividing by x minus 3, we had to subtract all of these polynomials, and that's why the subtraction was really cumbersome. When we, instead of putting x minus 3, when we write this as a positive 3, then what happens is these numbers there become opposite signs of what they were here, so we don't have to do any subtraction anymore. We end up adding. In fact, you can kind of see, I haven't really shown you the process yet, but you can kind of see right here that the -7 plus 6 gives me this plus this gives me this, and this plus this gives me this. So one of the main advantages of synthetic division is that you no longer have to subtract, you can just add things together, which is much, much easier to do. All right, so let's get to the process. We drag the first number down, that's our starting point, right? And then what we want to do, I'm not going to do this for every problem, but just to explain it to you, I'm going to draw a little arrow through here, right? And in this arrow, I'm going to write 3 times 2, because what I'm doing is I'm taking 3 times 2, and I'm going to write it in this position, which is 6. That's what this means. 3 times 2 arrives in the 6th position. Then I just take -7 plus 6. -7 plus 6 is -1, right? Once this number is in place, then I'm going to, again, kind of carve through the 1 position here like this and say 3 times the -1, 3 times the -1, which is -3, which goes in the next position right here. And then I add these together. 0 plus a -3 is -3. And then once I have this in position, Then the same thing happens here. I go through here, and it's going to be 3 times a negative 3, which is negative 9, like this. And then I add these guys together, and it's negative 4. So then I've arrived at the answer. Notice that's what I showed you here. I said, I just didn't put all these arrows everywhere. I said, you wrote the problem statement down. There's some intermediate numbers, 6, negative 3, negative 9. That's where they come from. And then you have the answers on the bottom. The very last number here is the remainder. And then everything before that is the actual polynomial. Now, when you're writing the answer down from synthetic division, you know this is an x cubed polynomial because this is a constant term, this is an x term, this is an x squared term, this is an x cubed term. So because this is an x cubed term, you know that this has to be a 2x squared term. You know this has to be an x term. You know this has to be a constant term. And then this is the remainder, which is negative 4, over whatever I divided by, which we know is x minus 3, because it's the opposite signs what we put up there. How do you know that the answer you write is actually squared here? It's because when you look back to the long division problem, this is why I wanted to do it first, we're dividing into a cubic. And we're dividing by x minus something. So you always have an answer that's going to be 1 degree lower than what you're dividing into when you're dividing by x minus something, right? You can see the answer was x squared when we're dividing into an x cubed. So when we're doing synthetic division, because we always have to divide by x plus a number, x minus a number, the answer you get is always going to be 1 degree lower than what you're dividing into, okay? So here's the procedure. You write down the numbers of the polynomial you're dividing into. You write down what you're dividing by. But you have to put a different sign, the opposite sign of what you're dividing by. We were dividing by x minus 3, so we put a 3 there. We drop the 2 down. 3 times 2 is 6. Okay, great. Add these together, we get a 1. Okay, 3 times negative 1 is negative 3. Great, we add these, we get a negative 3. 3 times a negative 3 is negative 9. We add these, we get negative 4. All the numbers in the bottom represent your answer, and notice we didn't have to do any subtractions. The reason we didn't have to do any subtractions is because we write the problem while we're dividing by, we basically change the sign. Instead of x minus 3, we divide by x plus 3. That ends up with the effect of making all of these numbers opposite in sign to the long division, so we don't have to subtract them anymore, we can just add them. That's the reason why it works. But procedurally, you just multiply, add, multiply, add, multiply, add. You have the answer here. This is the remainder divided by what we're dividing by. That's the fractional part of the remainder. And then this is the whole part of the polynomial answer. All right. Now that you have the procedure in place, we can go crank through 2 more problems that are going to be really, really fast now. Let's say that you're doing 3x cubed minus 5x squared plus x minus 2. And we're dividing that by x minus 2. Now, if you were doing long division, you would have to write this whole thing out and then do all the stuff with the subtraction, and it'd basically take the whole board, right? But since we're doing synthetic division, we don't do that. We take the numbers, we take away the numbers and strip away all the variables, and we write it under this house here. So 3 is the first number, negative 5 is the next one, 1 is the third one, and negative 2 is the last one. Now we have cube, square, first power, no power, so we're not missing any terms, so we don't need any zeros here. But if we were missing, for instance, the x squared term, if it was just 3x cubed plus x minus 2, and this one were gone, then we would have to put a 0 here. It would be 3, 0, 1, 2. You have to pad the zeros, same as long division. Then you put an upside down house, and you're dividing by x minus 2, but you don't put a minus 2 here, you always flip the sign. You can think of it like this. In synthetic division, we're allowed to add instead of subtract. So when you're dividing by something, you just flip the sign of whatever it is. And notice it has to be x minus something or x plus something in order to even do this at all. All right, now we're ready to do a very simple process. We take the 3, we draw a little arrow, we drop it down. 3 times 2 gives me 6. No need to draw those arrows now. We know what we're doing. 3 times 2 is 6. Then we add these. Negative 5 plus 6 is just the number 1. Then 2 times 1 is 2. Then we add these 2 to give us 3. Then 2 times 3 is 6. Then we add these to give me positive 4. Let me double check myself. 3, 1, 3, 4. Now, I think you can agree that this process is way more cumbersome and complicated than this process. So again, just one more time from the top. Drop the first number down. 3 times 2 is 6. Add, get a 1. 2 times 1 is 2. Add, get a 3. 3 times 2 is 6. Add, get a 4. And you always know that this number at the end is the remainder. Everything else before it is the rest of the answer, basically. So the way you're going to write it is, since you know that this is a cubic here, this represents the cube term, the x squared term, the x term, and the negative 2 term, then the answer here has to be 3x squared plus x plus 3, because it has to be 1 degree less than what you were dividing into. And then you have the 4 as a remainder divided by the x minus 2. This is the whole answer. 3x squared plus x plus 3 plus fraction 4 over x minus 2. That's all done. Synthetic division is a really, really huge time saver. And there's also other uses of synthetic division we're going to discuss a little bit later. Right now we're just doing it just to divide polynomials, but there's actually some other uses that we can use this technique for, a little bit later. Now what we're going to do is our final problem, just to get one more bit of practice. Let's say that we have the polynomial we want to divide is as follows: x cubed plus 3x squared minus 2 times x minus 6. And we're going to divide all that by x plus 3. So you have to ask yourself, am I dividing by x minus a number or x plus a number? I am dividing by x plus a number, so I'm allowed to use synthetic division. If I were allowed, or if this problem were different, if it were all this junk divided by x squared plus 3, then you can't do it. You can't use synthetic division. You have to go back and use the long division method. That works for everything, okay? If you're dividing by x cubed plus 3x minus 2, you can't do it. It only works when it's x plus a number or x minus a number. All right? So then what we're going to do is write down the relevant information. This is a cube, a square, a first power, and in the no power we don't have any missing terms. So it's just going to be 1, 3, negative 2, negative 6. Draw my upside down little house. And then we're dividing by x plus 3. You put the opposite sign of whatever you're dividing by there. That is really what allows us to do addition instead of subtraction. So that's the way to remember it. Whatever you divide by, just change the sign of it. And then you draw your horizontal line, and you drop a number 1 down here. And then you say negative 3 times the 1 is negative 3. I add these and I get a 0. And then 3 times 0 is 0. And I add these and I get a negative 2. And then the 3 times the negative 2 is positive 6. I add those and I get a 0. So I get 1, 0, negative 2, and 0. Now notice the interesting thing here is the remainder is actually equal to 0. So this is one of those examples where if I had done this long division way, I would get all the way down to the bottom, I would do my final subtraction, I would get a 0. So I would not have a fractional part, because it would be, the fractional part would be 0 over this, which is 0. So I can write the answer down even easier than before. I know that it's a cubic, I'm dividing by, so this has to be x squared. 1x squared plus 3x. Oops, I'm writing the wrong thing down. I'm sorry about that. I'm sorry about that. What I have here as an answer is 1x squared plus 0x minus 2. This is the answer. Or you could just write it as x squared minus 2. X squared minus 2. So the answer is x squared minus 2. All right, so that's the process of synthetic division. It makes our long division problems much, much easier to solve. Only thing we have to do is remember that when we're dividing by whatever we're dividing by, it can only be x plus a number or x minus a number, and we have to write the opposite sign in front of the synthetic division symbol. After that, this process is really, really fast, right? And we have other uses for it. We have other theorems that use synthetic division. I'm going to show you a little bit later. But for right now, use it to solve your long division problems whenever you're dividing by x minus a number or x plus a number. Solve all of these problems. Follow me on to the next lesson. We're going to get a little bit more practice with synthetic division.